Today let's talk about securing IP routing and remote access on Cisco routers. Before starting the content, let's talk about what is to be covered in this video. We'll go to the introductory part, then what exactly is IP routing we'll see, why do we need to secure IP routing and its types, how can we secure it, then we will talk about what is a remote access and how it can be done, and the last part is how to secure remote access and the summary. So let's start. Okay, so let's talk about the introductory part first. Cisco equipment comprises of a large part of the internet infrastructure and can be used by the large companies. Cisco is a big large company that comprises of the internet infrastructure. So routers provide physical connectivity between the networks by their physical attachment to either LAN or WAN. Cisco routers have several vulnerabilities that can allow the hackers, yeah, that's the point, that will allow the hackers to disrupt the network traffic, to disrupt the internet traffic, intercept, and steal the information such as password or credit card numbers or any important things like your emails from their websites. So securing the router is the first priority that the system admins need to do it before implementing any network. Secure routing and remote access are the ways of securing your routers. So what is basically a IP routing? IP routing is a term for the set of protocols that determine the path that follows in order to travel across multiple networks from its source to its destination. So it's a protocol that is followed so that we can send the data from source to destination, like from router 1 to router 2. IP routing allows us to control the flow of routing data to and from the routing tables. So data is routed from the source to destination through a series of routers and across multiple networks. Okay. Every IP router maintains a routing table of the current routing information. The IP routing table managers receive the routing updates from the network through IP on the router. So the IP routing protocol enables a router to build a forwarding table that correlates the final destination with the next hop address. The next hop address is the next router's address. It will enable them to build up the forwarding router table, so the next router table from it to its destination. There are two types of classes in the IP routing protocol, that is internet gateway protocols and an external gateway protocol. So let's talk about these two in a separate way. Like we will do study, we learn what are those two protocols. So the first is the interior gateway protocol. So what is an interior gateway protocol? An IGP, that is an interior gateway protocol, is a protocol for exchanging routing information between the gateways within an autonomous network. So the data or the information is exchanged between the gateways with an autonomous network. The routing information can be provided or can be used by the IP or other network to specify how the routing goes or how transmission occurs. Before going to the interior, before going to what are the supported routing protocols, I want to tell you there are two types of interior gateway protocol: distance vector routing and a link state routing. Though those are two different routing protocols. So what is a distance vector routing? Distance vector routing sends the entire routing table and it does not know the network topology. There are multiple protocols in this distance vector protocols, like as shown in below: RIP, RIP version 2, IGRP and EIGRP. So what are these protocols? RIP protocol is a dynamic routing protocol which uses hop count as a routing matrix to find the best way between the source and the destination. Second thing is IGRP. What is an IGRP? It is a it is a distance vector routing protocol produced by Cisco. As it is mentioned, it is a distance routing protocol. It is produced by Cisco. Enhanced Internet Gateway Routing Protocol, that is EIGRP. It is also a protocol, distance vector protocol, that was designed to follow on from the original IGRP protocol. So we need to understand what is IGRP protocol. So IGRP and IGP, the definition is almost the same, that it is used by routers to exchange routing data within an autonomous network or the system. It is a priority protocol. It was created to overcome the limitations of RIP when it is used within a large network. So now let's talk about link state routing. A link state routing that sends only a link state information, but he knows the entire network protocol, the entire network topology, but distance vector doesn't know. So the types are OSPF and ISIS. OSPF, or Open Short Path First, it is that was tailor made for IP networks using the shortest path first algorithm. The shortest path first algorithm to find the shortest path. And the second one is intermediate system, that is ISIS. It is a link state IP routing protocol and IGP protocol that is used to send IP routing information. It uses a modified version of Dijkstra algorithm. So next type in the IGP protocol is exterior gateway protocol. So what is exterior gateway protocol? It is a protocol for exchanging routing information between two neighbor gateways in a network of autonomous system. So it is commonly used between hosts on network to exchange routing table information. A routing table consists of a list of known routers, the addresses they can reach, and a cost metric associated with the path to each router, so that it is available the router is chosen. The types of EGP protocols are path vector routing protocol. There is only one path routing vector protocol. What it does, it maintains the path information that gets updated dynamically. The main drawback is the size of the advertisement, which grows with the number of hops. In the path vector routing protocol, there is a border gateway protocol that is mentioned below. It is a routing protocol that is classified as a distance vector protocol. As I told, it was designed to replace exterior gateway protocol with decentralized approach to routing. So the next is, we have talked about IP routing. So how we'll secure it? The first thing is IP spoofing. So what is an IP spoofing exactly? IP spoofing is the act of creating an IP packet with the forced source of IP address. That is like making a false IP address or a fake for the purpose of hiding the true source IP address, usually for the purpose of launching special types of DDoS, that is distributed denial of service attacks. By fogging the source of the packet, the individual sending it can direct the target's IP address machine to send its reply packet somewhere other than the real IP address of the source machine. To understand this, I have shown a figure below what exactly it means. Suppose like this is a server and this is a victim. Now a someone interpreter comes like a hacker, and a hacker will send the message as a bot. He will send as a bot, but to the server it will be like it is sent from a victim, that is this PC, like a server and a client is a victim now. So he has said, please send me a lots of data. So the hacker had said that, please send me a lots of data, and he sent that as a victim, and the victim gets all the data he's requested, but the victim didn't. This is called an IP spoofing. The anti-spoofing, which tells the server to reject any external packets that appear to come from an internal IP address, which cut down most of the spoof attacks, making all synchronous acknowledged dialogues more difficult to predict, will reduce the chances of getting interpreted and hijacked. So, how it can be prevented? IP spoofing can be prevented by securing a transmission packet and establishing screening policies. A point-to-point encryption will prevent unauthorized users like hackers from reading the packets, thus preserving the confidentiality of the data. Authentication can prove that a legitimate source and not a spoofed middleware like middleman sends the contents of the packet. There is a command here to use anti-spoofing using access list. So the access list 10 will deny ICMP of any type, and this will deny the IP address and the inverse of the subnet mask. So we have to specify the IP address which we want to deny the packets from and the inverse of the subnet mask. Another thing is anti-spoofing using RPF. Okay, so what is an RPF? RPF is a reverse path forwarding technique used in modern routers for ensuring loop-free forwarding of multicast packets. So the above command is this IP verify unicast RPF. The above command will discard spoofed IP packets in a symmetric routing environments with CEF only. What is a CEF? CEF is Cisco Express Forwarding. See, unicast RPF checks if any packet received at the router interface arrives on the best return path to the source of the packet. So unicast RPF does this by doing a reverse lookup, that is RPF, in the CEF table. The second type of attacks, or why we need to secure IP, is because of denial of service attack. So what is a DOS? DOS is a type of attack that is used or that is actually done to shut down a machine or a network, making it unusable to the users. DDoS attacks accomplish this by flooding the target with traffic or sending it information that triggers a crash. Like, for example, making the server busy so that it cannot be accessed. So, degradation of services occurs when the attacker causes the performance of the system or network due to overloading of the system targets. So let's see the type of the DOS attacks. First is a buffer overflow attack. It is the most common DOS attack. The concept behind it is to send more traffic to the network address than the programmers have to build the system to handle. They will send more traffic to the network address than the programmers have to build the system. It includes the attackers listed below, in addition to the others that are designed to exploit bugs specific to certain applications or network. So we'll talk about buffer flow network later. Let's talk about the types first. The second type is ICMP flood. Leverages misconfigured network devices by sending spoofed packet that ping every computer on targeted net instead of just one specific machine. Network is then triggered to amplify the traffic. This attack is also known as Smurf attack or a ping of death. The third type is SYN flood. Sends a request to the server but never completes the handshake. Continues until all open ports are saturated with the request and none are available for the user to connect. The third type is unauthorized routing updates. This security feature is utilized whenever routing updates are exchanged between the neighbor routers. So when we exchange data between router 1 to router 2, data is in updates. Neighbor authentication makes sure that the router will receive reliable information, routing information from the other router. Routing information can be easily spoofed and injected into the backbone. RIP version 2, ISIS, DRP server agent, OSPF, etc. are the only one routing protocol that supports neighbor authentication. So there are two types of neighbor authentication. There is a plain text authentication and an MD5, message digest algorithm version 5. So let's see what is a plain text authentication. Each participating neighbor shares a secret key to the router, which is specified on each router during configuration. Multiple keys can be specified, but a number key must identify each key. For example, let's see the below diagram. There are two routers, router A and router B. If a router A wants to send routing updates with a key and a corresponding number to the router B, that is this, which is its neighbor. Router B will then check the received key against its own key stored in its memory. If it is matching, that it will update the router, that it will accept it. If the key doesn't match, it will reject it. The second type is MD5 authentication, the message digest Message Digest 5 authentication works similarly to the plain text algorithm, but the main difference is the key number never sent over the wire. In Message Digest 5, it will use an algorithm to produce message digest of the key. This is also known as hash. Message digest is then sent, making sure that nobody can eavesdrop, nobody can see, nobody can edit on the line during the transmission. So before going to this, so let's go to this figure. Router A and router B. There are two neighbor routers. So first it will take the routing updates, convert it to hash, and then convert it to signature and send it to the router B. The router B, the signature and the routing updates. The signature and the signature of the router A and routing updates of his, then it will hash the signature and his routing updates and check if they are equal. If they are equal, you will get access. If they are not equal, you will be rejected. This is an example. This interface Ethernet 0, we will take an IP address 192.168.1 and 255.255.255.0. This is a message digest of OSPF. This is the OSPF, and this is a message digest. Message digest is exactly what? 50 is a message digest ID. This is message digest key. It is an ID. And MD5 test is actually an MD5 key. MD5 key is test and ID is 50. So next let's talk about what is a remote access. Remote access is an ability to get access to the computer or network from the remote distance. Home users can get access to the internet to the remote access to an ISP like TeamViewer. We can access the remote machine from the TeamViewer. Dial-up connection to desktop, laptop, mobile, or the handheld computer or the regular telephone lines is the common method of remote access. Some of the way we will see how we can remotely access. The first one is telnet access on Cisco router. We will need to know what is a telnet. Telnet is a protocol that produces command line interface like terminal or the Windows CMD for communication with the remote server or the local host server. Telnet programs are a type of programs of terminal emulation program like modem-based communication program. The difference it allows you to access other systems IP through the internet rather than by dialing direct. Admin functions can be achieved using telnet to access the router either physically through the console port or remotely to virtual terminal. SSH that makes the tel session more secure. So there is a command below. There are commands actually. Line VTY024. This line VTY024, it will take virtual terminal and allow 5 connection from the virtual terminal. And you can type the password. And what is this login? Login is when to use this password. Now we have to enter the password. So where we will use it? We will use it in login. That's why it is typed as login. And then we will exit. When we will telnet the other router or any of the router you want, once you have configured this, it will ask for the password first to configure that router. The second type is HTTP server access on Cisco routers. The HTTP server was introduced to extend the router management to the World Wide Web. This means the administrator can update or make changes remotely via web. The Cisco have released an adversary regarding the iOS HTTP authorization vulnerability. This vulnerability allows an intruder sending a crafted URL to execute privileged commands on a Cisco router if local authentication database is used. The intruder will be able to exercise complete control over the device. So through the web we can access it. After this, the question comes, after all this stuff, how we can secure the remote access. First is using ACL. ACL is access control list. System admin can restrict the telnet session to be from a trusted source network or an IP address. By default, there are no access control on any virtual terminal ports. This will add a layer of difficulty for hackers to break. The hackers then needs a trusted connection to access the router. There is a command below. This X55 will permit the TCP protocol with the IP address of 192.168.10.1 and is inverse of subnet mask 0.0.255. Any log is that it will save a log into the sys log file. Similarly, it will deny any TCP of any range, similarly UDP and IP. The above command, the above IP address, only this IP address will be permitted. So only this network will be allowed and other types will be denied. So second thing is using authentication. Authentication can be implemented using a username and password, like how a Gmail is having a username and password. By default, password is the only authentication to log in into the router. Using the username and password increases the level of effort need to use the brute force to crack the password. Brute force is a technique that is used by the hackers to hack the password. Each user that has the access to the router gets a separate user ID. So there is a command here, username admin1 password dot. It is a big number. We can add any password like admin1, admin123, admin at the rate. Suppose the username is Rohan, admin at the rate Rohan, and his birth date, etc. So we can add. What this exactly means? This is actually user is admin1 and admin2. There are two users now that will have the access to the router when they enter their specific password. The telnet session will prompt for the username and password when we will access the router. These two admins will use their separate password to log in. The third thing is using console port timeouts. When you are logged in into the router, we leave it, right? But leaving the terminal logged in can cause use up of the virtual terminal ports. To handle this, we need to configure shorter timeouts. By default, the timeout is applied on all connections to the console, aux, and virtual terminal. Each 10 minutes. The default timeout is 10 minutes. Can be controlled by applying exec timeout command on the router. Exec is execute. Enabling TCP keep alive on incoming connections will ensure that any remote connection that crash or get disconnected will not use up the remaining router's ports. So this is the same virtual terminal 5 users. This is an executive timeout of 5. This is a minute and this is a second. 5 minutes. If it was 5 then it will be 5 minutes 5 seconds. The service TCP keeps alive in. The TCP keeps alive is what? It will monitor the TCP connections to and from the router. They can terminate the connection if the switch has not received any response from the remote server or the remote device. The fourth thing is to disable HTTP server configuration. This vulnerability is to disable the HTTP server on a Cisco routers. The below command is how to do it. We just have to type no IP HTTP server and it will disable the server configurations. And the last thing is enable TAC ACS plus or radius authentication. So what are these two? TAC ACS plus is a security application that provides centralized validation for the users attempting to gain access to the router or network server. This provides for separate and modular authorization, authentication, and accounting facilities. This protocol TACACS Plus provides authentication between network access server and TACACS Plus daemon, and it ensures confidentiality because all protocol exchanges between the network server and TACACS Plus daemons are encrypted. So authentication is what provides a complete control over authentication through the login and password dialogues, challenge, response, and messaging support. This was about TACACS Plus. Now, what is Radius? Radius, the full form of Radius is the remote authentication dial-in user service. Radius. It acts as an access server authentication and accounting protocol. In the TACS was authentication, accounting, and there was authorization. It is a client server protocol, communication between a network access server, that is NAS, and the Radius server is based on UDP protocol. The Radius server can support a variety of methods to authenticate a user when it is provided with a username and original password given by the user. It can support PPP, PAP, or CHAP, Unix login, and other authentication mechanisms. This was all about it. So, the summary of it is what? We should configure a secure IP routing and telnet access should be a must in a Cisco router environment in order to improve the security. Many other features like packet logging, quality of service features can be used to increase the security level from the various attacks or from the hackers. Securing the router is the first thing that needs to be completed before any tools used to defend networks are implemented. This was all for it. Thank you so much.